Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking HPE Vertica for sponsoring today's event. HPE Vertica is an integral supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Alteryx, Dell Statistica, IBM, Teradata, Tableau, and Exaptive, to name just a few. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had an opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled Optimal Data Analytics Architecture, presented by HPE Vertica. And before we begin, I'd like to briefly review the format of today's webinar. In today's event, it'll be 1 hour long. We have two presenters that I'll introduce in just a minute. There'll be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. So I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. So I'm very pleased to introduce our speakers today, Steve Sarsfield of HPE Vertica and Mike Gualtieri of Forrester. Now, Steve is a product evangelist and spokesperson on HPE Vertica's team. He's also a big data enthusiast and the author of the book, The Data Governance Imperative. Now, Steve has more than 20 years of experience in big data analytics, information quality, big data, and data governance. Now, Mike's research with Forrester focuses on software technology, platforms, and practices that enable technology professionals to deliver prescient digital experiences and breakthrough operational efficiencies. His key technology platform coverage areas are big data and IoT strategy, Hadoop and Spark, predictive analytics, streaming analytics, prescriptive analytics, and machine learning, data science, AI, and emerging technologies that make software faster and smarter. Mike's also a leading expert on the intersection of business strategy, architecture, design, and creative collaboration. So, Steve, Mike, thanks for being with us today. We're looking forward to your presentation. You know, an explosion of big data is rapidly changing the IT landscape. And while big data generates vast opportunities for new sources of revenue, customer insights, and operational efficiencies, it also creates new challenges for existing data infrastructure. So to keep up with this explosion and capitalize on new data-driven business opportunities, enterprises must select a data analytics architecture that fits the specific needs of their business and their structure of the data. In today's Data Science Central webinar, Mike Gualtieri, VP and Principal Analyst at Forrester, and Steve Sarsfield, Product Evangelist and Spokesperson for HPE Vertica, will discuss a newly commissioned study on enterprises that select the correct mix of analytical engines and the best database for each job. So they'll review how a diversity of analytical engines can drive greater ROI, which databases have distinct capabilities and sweet spots, and why no one database can do it all. So, Mike, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Bill. And hello, everyone. My name is Mike Gualtieri, analyst at Forrester, and I cover advanced analytics and big data platforms. So what I want to talk to you today about is some research that we did, a thought leadership paper commissioned by Hewlett-Packard Enterprise on analytics architectures. And whenever we do a thought leadership paper, it's always based upon primary research. And so for this paper, we actually surveyed data analytics professionals who are decision makers. And as you can see here, it's a global survey from many different industries. The respondents specifically have knowledge and responsibility for a broad range of analytics platforms. And what we attempted to find from this study is what are those primary analytical engines that companies are using to be successful with advanced analytics. And the business backdrop for this is really based upon business priorities. And we can see from this survey that of 3,000 global data and analytics decision makers that the #1 focus on big data and analytics is to improve the experience of the customers. That's probably no surprise. To improve products and services, reduce costs is always in there, and improve the ability to innovate. Now, this specific survey is of global data and analytics decision makers, and that is in line with other surveys we've done with the business priorities. So the good news is that data and analytics decision makers, their priorities are aligned with the business. Now, what's driving this priority for customer experience is what we call hyper-personal real-time relationships. So this is an attempt by companies to scale individuality, to scale personalization across tens, hundreds of thousands, millions of customers. That's very difficult to do if you don't have data about those companies and you don't have the analytics to support understanding what the specific characteristics, what the specific behaviors of customers. You cannot hope to treat them more personally without that. And increasingly, because of the digitally connected world, you also have to do it in real time. Now at Forrester, we call this the age of the customer because of this drive towards hyper-personalization. I just net that out and I call it celebrity. So in the digitally connected world, customers want and increasingly expect to be treated like celebrities. And what do we know about celebrities? Everything, right? If all of us on the line here walked into a cheesecake factory, what menu are they going to give us? They're going to give us the same menu as everyone else. That's not personalized. But if they knew George Clooney was coming in, they would prepare a specialized menu that included prosciutto front and center because that's what he likes. So hyper-personalization is about understanding our customers as well as we understand celebrities. And to create these new celebrity experiences, enterprises have to learn individual customer characteristics and behaviors. That's going to come from data and analytics. Predict what those customers' needs and desires are in real time. That's going to come from advanced analytics. And then we have to create a whole new set of applications that can adapt to serve that individual customer in real time. And critical to the customer journey for all of these experiences is to make accurate decisions, to be as accurate as possible about that individualization. So the way we need to do this is we need to make better decisions. We need to be able to make decisions from the data. And the success of all enterprise operations, including customer experience, depends on the collective efficacy of those decisions about the customers, about the operations, and about strategy. And the ability to rapidly model, improve, and change that decision logic. So the decision logic is the end game because that's what's going to create that personalization in the applications. And we also have to scale it. So this isn't about someone sitting in front of a visualization software to quote unquote gain insights. This is about creating automated embedded analytics and models that can make those decisions within the application so that we can scale it to millions of customers. So of course the raw material for this is data, and it's been popular to say that big data is the new oil. We don't really agree with that. We think that data is more like the sun. It's virtually limitless and mostly untapped by organizations. We did one survey where we asked companies to estimate how much of their data they're analyzing. We didn't even ask them what types of, in this survey, we didn't ask them what types of analytics they're doing. And they estimated, on average, about 17% of their data. So there's a big opportunity to analyze data that's not being analyzed now. We also know that firms have plenty of data to analyze. You can see this chart here where we ask them about structured, semi-structured, and unstructured data. And the biggest amount there is in that 10 terabytes to 99 terabytes range. That's a lot of data. You can see there's even 13% of the companies say that they're over a petabyte. So there's plenty of data to analyze, but not a lot of analysis going on. So once we have that raw data, we need the analytics, because the data is nothing without the analytics. And enterprises have to use any and all types of analytics to improve those decisions, to create those hyper-personalized customer experiences. And we call this, and these decisions have to support decision makers and digital decisions and applications. So certainly traditional business intelligence creates reports, dashboards that support people making decisions. But we also need to create analytics and predictive models that can be embedded in applications. So traditional BI shops are not thinking as much about analytics embedded in applications, and application development teams aren't thinking about how they can use analytics in their application. So we call this combination of analytics prescriptive analytics, because they are specifically focused on that decision logic. And prescriptive analytics isn't any one particular type of analytics. It's any combination of analytics. It could be math, data experiments, simulation, and even artificial intelligence methods used to improve those decisions, used to embed models that will make those hyper-personalized decisions. So a lot of people say that prescriptive analytics is the next thing after predictive. Well, not really. Prescriptive analytics could even be a predictive model. So prescriptive analytics is the umbrella. It's a focus on improving decision logic. And the categories of prescriptive analytics there's several. There's descriptive analytics, which is typically BI, predictive modeling, streaming analytics, which is all about real time, but it's also about search technology, knowledge discovery, simulation, mathematical optimization, and there's an overlap between machine learning and artificial intelligence. So all of these forms of analytics are needed to be used in conjunction to create the best possible decisions. Now, prescriptive analytics, it informs, so it can be used in the decision-making process, but it can also be used to evolve the decision. So based upon the statistics about the effectiveness of the decision, how personalized, did it work for this user, did it work in the company, that information can feed back into the analytics to improve the decision. So analytics can inform decision logic directly, but it can also be used to evolve to create more effective decisions. So in order to make use of all of these analytics, we need analytical engines. And what our study sought to find out is what sort of analytical engines are enterprise using, specifically large enterprises. And our perspective and our hypothesis is that organizations need multiple analytical engines to uncover and use all of those forms of prescriptive analytics. And every analytical engine that's possible to use, we find companies are using some subset of those. So you can see here sort of the full spectrum of streaming analytics for real time, relational database management system, NoSQL are focused more primarily on transactional, search technology, graph databases, a data warehouse, and then Spark and Hadoop. And part of the hypothesis here, and one of the reasons why we sought to do this research, is that we know that more than 56% of large enterprises have adopted Hadoop. And there's been some perspective out there that Hadoop is taking over all of these other analytical engines. So one of the questions that we sought to find out is that true? And we found from the data that organizations, while they do use Hadoop, they don't rely on any single analytical engine. So the average number of tools or resources implemented are, this is a statistic, so it's 2.7. right? You can't have 7/10 of an analytical engine. But it's not all about one particular analytical engine. They're actually, on average, using multiple, close to 3. So if we look at each one of these and how it fits in creating those hyper-personal relationships and improving decision making, streaming analytics is the first engine. And this is probably one of the engines that's least used by enterprises and probably most misunderstood. But streaming analytics looks at events that are occurring in real time and looks for patterns in that events. Patterns to detect and act on insights that you can't wait to act on. So for example, if a user gets off a plane, the phone detects a new GPS location, that's potentially an actionable event. So streaming analytics can detect and act on those perishable insights. So it's a critical analytical engine if what you're attempting to do is create real-time experiences. Now, of course, the relational database, that's a transactional database, so it's optimized for writing to that database. But whenever there's a transaction, that is an indication of a relationship with a customer and presumably a high-value relationship because a transaction is taking place. So the transactional engines often have the freshest data, the freshest and most valuable interaction with the customer. So there's analytical possibilities to be embedded in that relational database. Now, it's not optimized for analytics, but you can do things like embed predictive models in a transaction to enhance and make that experience more personalized. And of course, NoSQL databases such as MongoDB or Cassandra, they store multi-structured data. That's often also used in transactions. The difference is that NoSQL databases are clustered. So they scale very well as key value stores, but they haven't displaced relational database systems because they're not as good on the transaction processing. But NoSQL databases often contain very, shall we say, more ancillary data that can be used for analytics. Search technology is often overlooked as an analytical technology, but it's absolutely critical. I mean, if you think of Amazon Echo or Siri or Google, and that interface where you're asking it a question, what technology do you think it's using behind to find that answer? Certainly it's using voice recognition and NLP to try to determine what you want. But once it determines that, it's going to use search technology to find the answer. And there's no reason why enterprises shouldn't use search technology to improve their customer experiences as well. And the advantage of search technology is that it scans all types of data. So it can be unstructured, it can be semi-structured, it can be in documents, and it can even be in databases. So search technology is a really important personalization technology for analytics. Some companies are also finding value in graph databases because they can find relationships among different data. So you might think of this finding interesting relationships between your customers. Some people use it to analyze social media graphs. And a graph database is a very specific analytical engine. And many companies are starting to use it, but it's still underused, especially for what it's best at, which is just finding these distinct relationships. We also have a Columnar data warehouse, and this is sort of the workforce of the enterprise. It's designed for high concurrency. It has very performant and compliant SQL for queries and advanced analytics. And what's interesting about the data warehouse is that it is optimized for reads. It is optimized to scan huge data sets and find aggregates. And this is very, very important for finding not only BI, but real-time analytics as well. And many of these data warehouses also can do push-down processing of things like machine learning and statistical operations. So it's also a critical technology. And then we come to Hadoop. Now Hadoop is a general purpose storage and batch processing platform. So unlike the prior technologies, Hadoop is general purpose and it's a batch processing system. So are there SQL engines on Hadoop? Absolutely. Are there machine learning on Hadoop? Absolutely. So it's very general purpose, but it's important to note that it's a batch processing platform. Now, Hadoop has become popular because of the economics of Hadoop. The cost to store data in Hadoop is much lower than some of the other platforms, and it also has a scale-out architecture. But you do make some sacrifices when you do that as well, which is in the speed of processing, because Hadoop is a batch processing. Now, people say, oh, well, Hadoop's very fast. It's very fast because it can divide and conquer. It can distribute a workload. So it's very fast from a batch processing standpoint, but it's insufficient as a real-time platform. And then finally, Apache Spark. Spark is also a general purpose platform, not unlike Hadoop, except that it's been designed to be in memory. So Spark can spill to disk, but its primary design is to load data sets into memory. And Spark also is often co-located in Hadoop. So Hadoop is used for the storage, and then Spark is used for the processing. People don't really use you wouldn't use MapReduce now for most analytical jobs. You would write those jobs in Spark and load the data from Hadoop. The thing about Spark, though, is it actually doesn't require Hadoop. You can have a Spark cluster totally on its own, and Spark can load data from basically any source. Now, Spark is a batch platform, and if you know anything about it, you might be saying, well, what about Spark Streams? That's a streaming. Isn't that a real-time streaming platform? No, it's not, because Spark streaming is based upon a micro-batch architecture. And really what that means is it means, hey, if we run a batch job every 500 milliseconds and we just keep running it, it starts to look like a stream. So that approach is sufficient for many applications, but it's insufficient for the lowest latency of applications. So we think that enterprises can have value from all of these analytical engines. They all have a sweet spot. And from our survey, we found that companies find that it's worth the investment. We asked them here, what is the estimated return on investment you've currently seen so far, each of the following tools. And you can see that the companies that reported having most analytical engines, so you see that at the bottom, number of analytical engines implemented, report that they have a higher return. This was the most telling chart for me in our study. So here's what you have to look for in these analytical engines. They have to scale to handle any amount of data. I mean, this is probably obvious, but everyone knows that data is growing. So whatever analytical engine you pick, it has to scale to any amount of data. Now, there's differences in how these platforms handle this, right? A transactional database is generally scale up, where a data warehouse uses an MCP architecture so that it distributes that load across multiple processors, as does Hadoop, as does Spark. So there's different ways to scale, but there's trade-offs to that, which is why in our DBMS it's generally scale up. You also need to process and analyze that data as fast as possible. In-memory architectures are basically taken over in all of these platforms. No one really says in-memory anymore because most of these platforms have been re-architected or enhanced to use memory more effectively. And these engines you need to think of these engines as a critical part of your applications, a critical part of those experiences with your customers. So they also have to be fault tolerant, because these analytics aren't just sleepy backroom business intelligence. Someone asks for a report and they don't care if they get it tomorrow or the next day. We're talking about prescriptive analytics that are used inside of applications or models or in predictive models. And these analytics engines have to work seamlessly in existing enterprise architectures. So you have to look for engines that work seamlessly within your existing architectures, can connect with your existing applications. Look, if you think of a large enterprise might have a portfolio of hundreds to 3,000 applications. That's a lot of applications, and most of those applications may have some valuable data to be analyzed. Not all of them, but most of them. All of that data originates in those applications, so it has to get into one or more of these platforms to be analyzed. And finally, each of these analytical engines is a little bit different in how you do the analytics. If you're doing machine learning, that's one set of tools. If you're doing BI, that's another set of tools. Streaming analytics, something totally different. Same with search. So the platform has to support tools and offer APIs that business professionals, data science, and application developers can use to embed the analytics or models in their applications. So, you know, the point is that our data shows that businesses value customer experience as number one, and they're trying to build these hyper-personalized applications. They can only do that by understanding their customers better, understanding them in real time, and building data-driven applications. And enterprises are going to need multiple analytics engines to do it, so they have to keep their analytics architecture open. So rather than thinking, I can just replace all of my analytics with one specific platform, they have to keep these options open. And as I've shown you, there's many different approaches to analytics, and there's a sweet spot for each one of these engines. So final advice here and findings from our study is to implement and orchestrate multiple analytics engines in your organization to build the analytics and models you need to create those next generation customer experiences. So thank you for your attention, and now I'm going to turn this over to Steve Sarsfield. Steve?
Mike, thank you very much. That was a great presentation. I appreciate it. Very insightful for the research that you have done. So thank you very much for leading it off. I am going to talk about big data architectures as well. You know, I think the best part of my job is that I get to talk to many customers who are doing a lot of big data analytics, and they're talking about how they are solving problems, how they are overcoming issues within their organization. So it's great to see how some of Vertica customers are getting in and you know, tackling some of these issues. Most of our customers are big data analytic customers, so they have really big amounts of data. You know, our biggest customer has ingest about 60 terabytes per hour into Vertica, and then has thousands of users who are hitting up against the analytics. Now, certainly you don't need that big of a data, you know, in order to benefit from a hybrid architecture. But you know, if you have half a terabyte or something like that total in your enterprise, you probably, you know, can handle that within a single database. So we are talking about big data architectures here and when we talk about some of the things that we're talking about in the next couple of slides. So I think when we look at where companies are, it's also interesting to kind of look at where they've been and what they've been doing in order to solve analytical challenges. One thing is, you know, in the middle they have requirements, and the requirements for analytics usually are driven by whether or not they have structure in the data. So are they going to spend time putting structure around the data, or are they going to keep it sort of unstructured data? It depends on things like the workload that they have within the organization. So how many users do I have? Is my workload very complex? Am I expecting a certain response time, a certain SLA when it comes to performing analytics? But there's also other factors that kind of touch a little bit on data governance as well. So the politics within an organization. You know, do I have a CEO that likes one technology over the other? There's also the economic factors that they're looking at. So how expensive is the solution compared to the other ones on the market? So based on all these factors and more, they start to develop additional technologies technologies within their organization. So we may develop a data warehouse for handling the bulk of the analytic workload. We may do data marts if we want to take some of that workload off and put it onto separate servers. We may have a data lake that's in Hadoop. And using that data lake are data scientists who are doing data discovery. As Mike mentioned, streaming and operational analytics, they are becoming more and more popular within an organization. So, if I want to have real-time or near real-time analytics, that could be part of the architecture as well. Some companies out there are still sort of immature when it comes to performing analytics. So they may have spreadsheets and tables and things that they share around with regard to data. They may not want to spend the time putting structure around the data. There's great benefit in putting structure around the data. Usually you can get better performance and handle bigger amounts of data when you put structure around it. But they may not have time to do that or the resources to do that. So sometimes NoSQL is the solution for that. So this is kind of what happens in an organization. They build out these different infrastructures for, based on the workloads that they have and the requirements that they have. When folks go and they decide on what database they are going to use for an analytical workload, they look at things like structure. How much structure do I have within the data? Will I be able to take it and create schemas around the data, or is it easier just to put it into a NoSQL database? Is the size of the data a factor? Do I have huge amounts of data? Will the data ever be big data, or are we going to have sub 1 terabyte data that we can handle in almost any database? And then also we have questions about the analytics. What kind of questions do you want to ask of the data? Do we have a lot of short-running queries, or are we going back and looking at 3 years worth of data with long, deep queries with lots of joins and lots of where clauses within the analytics? So these are some of the deciding factors. Of course, there's the business aspects like, the cost per terabyte when we're buying licenses for technologies. There's staffing considerations. How familiar is my staff with the technology that we may be bringing in to the organization? There's things like financials, so I don't want to go out and ask my company, my CEO, for more money if we just had a bad quarter, right? So company financials come into play when it comes into deciding on whether we should use a new database for our analytics or just something that's existing within the organization. One thing I don't mention here is security. Security is a big factor in deciding it as well. So I know that security on Hadoop-based analytic solutions, tends to, you have to kind of work with it a little bit more. There's Kerberos and things like secure data from HPE that can help you with data security. So all of these things kind of go in and they contribute to factors when deciding, what database you're going to use for your next analytical workload. But when it comes to the analytical workloads themselves, if you really think about it, sometimes the analytical workloads require that you have multiple technologies around the database. The one that a lot of the open source community thinks about is the typical weather application. So if I want to build an application that tells me the weather, I want to have a database that will give me fast, short-running queries that will tell me the temperature right now, the temperature and pressure. If I want to take a look at what was the high and low temperature for my zip code, what was the high-low temperature for my state, what was the average temperature for this time of year when I'm looking back at multiple years of data, and what was the highest and lowest of all time. Those are deeper analytical functions that you have to really dig into. They may require a columnar store database or a bigger analytic solution than just sort of your typical heads-up display analytics. And then there are machine learning algorithms as well. So can we predict the weather based on the current data that we have? Can we use any kind of algorithms to do that? The same holds true, by the way, for things like security analytics. So I want to understand within my organization whether there are any attacks happening right now. But I also, if I see an attack, I want to understand has something like this happened in the past? Has anything happened like this over the last 3 years? What IP are these events coming through? So I might want to have deeper analysis with bigger data sets than just that quick query that's coming across. And then on your machine learning, on the machine learning aspects of it, what new events should we be looking out for and tracking in order to predict any security issues that we may have in the future? So even within just a simple application, needing different types of analysis is fairly common. So why not just put everything in your legacy data warehouse, right? We know that our data warehouse works. It's mature. We have users who know how to use it. My staff is trained on it. The analytical functions or the depth of the analytical functions are mature. And frankly, it would be fairly costly to replace. Well, certainly the legacy data warehouse is becoming more and more expensive. The pricing model of some of the legacy data warehouses out there are, kind of old school, right? So they become more and more expensive as the size of your data increases. There are real limitations on the size of the data, the number of users. I know that more within companies, you hear that the end users are asking for more analytics. But a lot of folks who manage the data warehouse, they're careful about who they open up the analytics to within the organization, because they know that can impact the performance of the day-to-day analytics that happen in the data warehouse. So also within the data warehouse, you tend to spend a lot of time tuning it, and a lot of resources tuning it. So there are folks who know how to make those indices and materialized views that make the data warehouse faster. So the data warehouse is a good solution. It's not the ultimate solution for everything, because it does have some limitations. I think we've been sold a little bit of a bill of goods that we should put everything in Hadoop and try to perform analytics around that, or perform all of our analytics in that. And Hadoop is a low-cost way to store data, and you can store it on commodity hardware. And any data with any relevance can be stored in Hadoop, so it's a great data lake. Also, having Hadoop capability these days is pretty cool to have on the resume. So if I have that capability, it's great to have training around that. But as you'll see later in the slides that I'm presenting today, there are real limitations around the concurrency of analytics. So if I want to have 1,000 users hitting up against my Hadoop data lake, it's not going to happen. It's very difficult to make that happen. There's real limitations around the completeness of analytical functions and analytical queries that we have. A lot of the SQL and Hadoop solutions that are out in the marketplace, they don't have things like specific data types like time, or they don't have things like the ability to do a where clause within a join. So completeness of analytical functions and analytical queries are a challenge. And then overall performance as well. So your legacy data warehouse is not really the solution to do everything, and Hadoop is not really the solution to do everything. Spark, it's hot. It's very hot, and so Spark is a great way to take data streams or micro batches, as Mike says, and load them in and use memory to really have fast analytics. So we can load this fast-moving data into the cluster of memory. We can do quick transformations. We can run machine learning algorithms. It's really well suited for just watching the stream, the Internet of Things and security analytics. But there are some limitations there as well. So this solution does require a lot of RAM, and it's expensive to put a lot of RAM into a cluster and have that. It would be better if you could, serve and have similar performance with data that's sitting on disk. So because of that limitation, the fact that you need a lot of RAM, it does spill over into disk, but you need a lot of RAM. Is it really a big data analytics solution that can handle the huge petabytes of data that you want? Is it really unlimited? I think also one of the things you have to look at with Spark is that it is early. It's version 2.0 today. it's not yet a platform. It doesn't have all the niceties that a platform has, like backup and management and all those things. So it's fairly immature. So Spark is really not your end-all solution when it comes to performing big data analytics and all the things that you may need to do with your big data analytics. One of the things that we looked at, or we have been looking at within Vertica, is just sort of the overall capabilities with regard to analytic functions. So here, what we did is we took the TPC-DS queries, which are standard queries for kind of understanding how in-depth you can go with your analytic database. And we said, okay, let's make sure that all 99 of the TPC-DS benchmark queries can run on Vertica and our product called HPE Vertica for SQL and Hadoop, which, by the way, is a analytical engine that you can install and run on Hadoop. So certainly all 99 of the 99 queries can run on Vertica, but with things like Impala, we got less than that. We got 80 of the 99 queries. With Hive on Tez, less than that, and with Spark, less queries ran on that. So not all of the analytical functions are available in all the solutions that are on the market today for doing big data analytics. A lot of times that those functions fail. So if we look specifically at the functions, let's see here, coming across, I hope. Try pushing that to audience. One more time. Okay, great. So, if we look specifically at the functions that, for some reason I can't see it, but my colleague says that he can. So, specifically at the functions that are really good for, that don't necessarily work in Hadoop, you're looking at things like functions around customer segmentation. You're looking at functions around location analysis and channel analysis. You're looking at things like net profit and revenue. So those things aren't as robust in some of the Hadoop-based platforms as they are in a real database. Geospatial is something you have to look for. Is that something that's built into the database or something that we have to add on and hook on to the function within Hadoop? Things like data type, I mentioned that. In-place join. So if I have a database, data in my data warehouse, and I want to do a join against Hadoop-based data store, can I do joins without having to move the data? So there are some major limitations around, using Hadoop and some of the other technologies in the marketplace for doing that. And in order to sort of get around those gaps, you may have to do some things like data munging, making sure that, during the load process that you're munging the data right. You may have to write some custom code. You may have to move and copy, big data. So, these are kind of limitations that are, available with some of the solutions on the marketplace. Let me see if this one pushes out. Okay, well, I'm not seeing it on my screen, but hopefully my colleague will tell me whether he is or not. So when it comes to
Steve, excuse me, tell me where you would like to be and I'll help you get to that slide.
Oh, sure. I am on slide 65.
Okay. Now that's live to the viewing audience. Go ahead.
Okay, great. Yeah, I don't see it for some reason, but that's all right. So considering concurrency, I think one of the tests that we took a look at and we did was that we said, okay, what happens, all the TPC-DS queries are usually one query at a time. You kind of put a query in and it comes back. What happens if you put multiple queries in? So we did a comparison of putting 1 long, 2 medium, and 5 small queries into Impala and into Vertica, and we let these queries run. Well, in our results, Impala came back very quickly, and it completed the 2 medium and 5 small queries, but failed on the long one, right? and Vertica was able to run through all the queries with the database. So I think it's key to think about how many concurrent users you're going to be using with the database, and consider concurrency when it comes to choosing your analytical solution and your analytical stack. All right, let's go to the next slide. So I think you can make a case for having tiering in the informational life cycle. So there needs to be within an organization sort of different layers within the architecture. You need to have a layer that ingests important data and analyzes data in real time. It understands some of the immediate challenges with the data. When it's done with understanding those immediate challenges, it can tier them off into a lower tier for deeper analysis. You need to have a tier that can provide daily analytics and meet an SLA. It can handle big petabyte scale data, be very cost effective when it comes to offering analytics, but also provide users with full SQL support. And then when it's ready, it can also tier data off to a lower cost structure. There can be also another layer necessary. Usually this is the Hadoop layer, where you're ingesting data of unknown value, you're storing it away, and you're keeping it for compliance. And if you build the slide out, you can see that there could be even another opportunity for end of quarter reports. So if I want to fire up extra capacity, extra analytical capacity for end of month or end of quarter, if I want to handle seasonal variations in my analytical capabilities, I can take some of that middle layer and I can fire up a cloud instance and provide that for extra support. So this is the tiering that we're kind of proposing when it comes to supporting the information life cycle. And we think these tiers are really well represented by Spark, Vertica, and Hadoop. And if you think about those three layers, there are different cost emphasis on this as well. So the most expensive layer is the Spark layer because of the hardware costs and the Spark expertise. The middle layer is fairly economical. You're paying really with Vertica your cost per terabyte, and you're paying your data warehouse expertise. And then the low level is Hadoop. You're storing data on commodity servers. You're paying your per node licensing. So as much data as you can load into a node is how much you're paying when it comes to your Hadoop license. So there's very interesting cost variations when it comes to setting up tiering within an organization. I think traditionally we've been looking at a legacy data warehouse where we're paying licensing costs, we're paying per user, per connected system, per processor, per amount of data. All of those things kind of combine in the cost. Plus we're tuning it, we're spending a lot on expertise and so on. So with this new model, we're thinking about the cost and we're thinking about tiering the data in different ways. So I know I'm running up against time a little bit here. So in our modern architecture, we do have HPE Vertica, we have Hadoop and Spark, and they each have their unique value. Hadoop is really great for the data lake, for cold storage of data, for doing data discovery. It is even pretty good at doing ETL, so you can do some sort of data munging when it comes to that. Spark is great for small, fast-running queries. So that in-memory capability that Spark has is great for doing those complex event processing operations, operational analytics, and so on. And then Vertica is great for that petabyte scale, deep analysis, many concurrent user analysis that we have. So what we've done is we actually have built features that allow us to connect, and share data among all of these three solutions. We have Kafka in the middle that allows you to share data, publish and subscribe mechanism between all of these three solutions. You can take and use HPE Vertica and do joins with data that's sitting in the data lake. So if you have an org file or a Parquet file and it's sitting in the Hadoop data lake, it's pretty easy to use your data warehouse to do a join and do some analysis for that data that's sitting in Hadoop. So it's great to build out, it's great for us to build out functions around this so we can support this open modern architecture. I would say that if you kind of look at the whole thing, not just the database part of it, you do have data sources. They're being usually connected and structured by things like Kafka and your ETL tools or your Talons or your Informaticas of the world. There are connectors that connect between the databases that allow you to share data between the two as well. You can adjust and transform with tools like Spark and VoltDB. You can set up your big data warehouse with Vertica, and you can set up your data lake with one version of Hadoop. With all of these things, you should be able to perform analytics using things like Python and SQL and R, and perform analytics back using those languages. Because you use those languages, you can visualize with tools like Cognos and Looker and MicroStrategy, Qlik, and Tableau. And then you should be able to enlighten your users with real-time dashboards all the way up to predictive analytics and ad hoc queries. So this architecture really does fit nicely together, and it usually fits nicely within the architecture that you currently have within your organization. I will say that we have some other companies that have done this, and so these are the guys that I talked to, companies like BlaBlaCar and Etsy and Cerner. And there is a book available on Vertica.com. If you go there, you can download that book and read about some of the case studies that we have for companies that have set up this tiering and this path to maturity that they have. I will also close out by just saying that if you want to try Vertica, we do have a trial of Vertica. If you go to my.vertica.com, you can use our community edition for as long as you want, for up to 1 terabyte. And you can manage and store and try the speed and performance of Vertica. We are a very fast database. We match some of the in-memory database capabilities in terms of speed so our Vertica Columnar store is a match for a lot of the in-memory databases. Very fast analytics, has massive scalability. I mentioned some of our customers who are really ingesting and using terabytes and terabytes of data. It's an open architecture with Kafka support and Spark, and we really have optimized our data storage, so you use less of it, use less hardware and less storage. So with that, I will hand it back to Bill, and I think we're ready for Q&A, Bill.
Hey, Steve, Mike, thanks for that excellent presentation. So we'll get started with today's Q&A session, and I want to thank the audience for their participation. We've had a lot of questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. So during this Q&A session, I'll leave up this screen that has contact information for Steve and Mike if you'd like to contact them following today's webinar. So let's get started. Steve, Mike, across all of these platforms, is SQL still the go-to query language that an organization should consider when they're choosing an analytical engine? Is that still the base query language?
Well, this is Mike. I wouldn't say it's used across all of those platforms. So, for example, search technology, that's a whole different type of query technology. But for most enterprise application data, SQL is still the go-to language. Incidentally, it's the most popular use case on Hadoop as well. Hadoop is 10 years old, and it started off in the internet companies, Yahoo, Facebook used it for unstructured data. And the thing about Hadoop, it's a file system, right? So it doesn't care what's in that file, but if you format that data in a structured format, there's a couple of formats for SQL and Hadoop. SQL is still one of the most popular ways to query data, and even there's SQL engines on Spark as well.
Well, Mike, thanks for that answer. And by the way, early in your presentation, you showed a slide that said something about the average company having 2.7 databases. One of them was always an RDBMS. Another one was Hadoop. Mm-hmm. What's in that 7/10? What is typically that third database that a lot of companies have?
Data warehouse.
Oh, data warehouse. Okay. All right. So
Yeah.
in the
Yeah.
category of Hadoop, you were lumping HBase and the Columnar versions and perhaps even the document versions and graph versions of that we would get from different distributions.
Yes. Yep.
Okay, great. And as a matter of understanding the language, our audience has asked, where do federated data models and data stores fit into this? How does our understanding of federated match with what you've presented? Not clear? Anybody?
This is Mike. Yeah, Steve, do you have a thought on that? I mean, I'm trying to think. Federated can mean a lot of different things. I mean, a lot of times a federated model means, okay, I've got one data model in this engine, and I've got another data model in this engine, but I want them to be federated. I want them to look as one. So I'm not sure if that's what you're asking or not.
Right. I understand the question from the audience may not have been completely clear. We do hear that word federated a lot, and it was interesting to get a response. With all of these different analytic platforms and all of this data, what are you seeing about companies and how they are organizing in order to track and define the attributes of all this data? Are they building one giant data dictionary, or how are they organizing to have a common understanding of what this data means across all these platforms?
Well, this is Mike. I'll go first, and I'm sure Steve has a perspective on this. But so it seems to always be the goal to have, to understand the data, to have metadata, to have a unified model. But it seems like a goal that many enterprises have trouble reaching for a couple of reasons. One is that there's just so many data sources. I mentioned before that an organization can have a portfolio of hundreds, if not thousands, of applications. And all of a sudden, the data scientist wants some data from some application source, right? And so just the sheer amount of intellectual effort that has to go into creating some model that makes sense is sometimes overbearing. The second reason why it's difficult to do is new technology. When you have a new technology like Hadoop come on the fold, okay, well, the idea there is to, as Steve said, take some data that you don't necessarily know the value of. So you might not want to spend a lot of time over modeling that data. So there's some sort of balance between identifying data that should be modeled in an enterprise way, as opposed to sort of a one-off modeling to get a particular job done. So that's sort of the tension between these two things. Steve?
Yeah, I mean, I have seen, 5-10 years ago, it was pretty popular to use an MDM solution to develop some kind of reference data, right, that you would use and use it sort of as your data dictionary, if you will, throughout the enterprise. I think you're right, though. I think we've expanded to the fact that, to the point that there's so much data that it's really tough to maintain that. Now, if you want to keep that reference data and keep it local to your ERP system or some kind of supply chain, that makes perfect sense to me. But if you're talking about all the data that's out there, all that's available, it's really difficult to devise an MDM solution that can keep and store a single data model and a single reference data for the entire organization. So it's becoming more and more unwieldy as time goes on here.
Well, Steve, Mike,
yeah, and
thank
Bill,
you
one
for
more,
some...
one more. Sure. I was just going to add one more observation to that, too, is a lot of companies are very interested in creating predictive models. And when you use machine learning algorithms to create those models, those machine learning algorithms want a completely denormalized flat data set of rows and columns. If you're doing a logistical regression or whatever algorithm you're using. And so sort of all bets are off for that type of thing. And that's where you have this quick hit and run of creating those type of data sets by data scientists. Modeling is not necessary.
Thanks for those great answers. Unfortunately, we're running really short of time. And for those of you that asked questions that weren't answered today, we'll send those unanswered questions on to Steve and Mike and the HPE Vertica team so they can follow up with you after today's webinar. I have just a couple of quick announcements. Please mark your calendars for January 31st. That's our next DSC webinar, going to be sponsored by Tableau, and their topic will be a natural language processing approach to data exploration. Also, please remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to HPE Vertica for their sponsorship, and our speakers today, Steve and Mike, for their insights into today's topic. My name is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on January 31st. Have a great day.